An intersection of art and science on the station. Presented by Science at NASA. Large and powerful telescopes have delivered stunning images of our galaxy and the universe. A little closer to home, my colleagues have taken some equally stunning photographs of our own planet from the International Space Station. My name is Mario Runco, and I'm an Earth scientist and former space shuttle astronaut. After seeing our beautiful home planet from orbit, I wanted to be able to share the experience with everyone. So one of the NASA accomplishments of which I am most proud was helping to spearhead the creation of the WRF, the Window Observational Research Facility on the ISS. My colleagues, Dr. Dean Epler and Dr. Karen Scott and I, envisioned a small facility, about the size of a large refrigerator, that would enhance the capabilities of the large Earth-viewing optical quality window that we were previously successful in getting aboard the station. This vision became reality as the WRF was launched to the station in 2010 on board the STS-131 mission of the Space Shuttle Discovery. The optical quality window and the WRF are a perfect blend of art and science. They allow us to conduct Earth science research and capture amazing high-resolution photographs of the Earth. The window is located in the U.S. Destiny laboratory module and features the highest quality optics ever flown on a crewed spacecraft. It is 20 inches or 51 centimeters in diameter and includes a non-optical quality retractable pane that protects it when it is not in use, but still allows natural light into the station and provides a great view for the crew. The WRF is capable of housing a variety of sensors within the shirt sleeve environment inside the space station and serve as a testbed for the development of new sensor technology. These sensors can be used to study atmospheric, oceanic, and surface terrain conditions, as well as make environmental health assessments. Observations made from the WRF can provide important data on transient atmospheric and geologic phenomena, such as tropical cyclones and volcanic eruptions. It also helps us to better understand our local solar system environment. The National Laboratory Meteor Investigation allows for spectroscopic analysis of meteors as they enter the Earth's upper atmosphere. The WRF's presence on the space station allows its sensors to image the same location or region multiple times over several days. This allows for observations that can show, for example, how vegetation below may be changing from day to day. Subtle changes detectable by orbital sensors that might be indicative of declining plant health are rarely visible on the ground in their early stages, and often by the time they are, it is too late and crops or even forests may be lost. My colleagues and I are all avid Star Trek fans, and we decided to name the facility WRF after the Honorable Klingon warrior. We designed a mission patch that included Klingon script for the acronym WRF, and even an alternate version with a depiction of an astronaut bearing an uncanny resemblance to Science Officer Spock making observations of the Earth from the WRF. For more of the many wonders that can be observed from Earth orbit, go to nasa.gov/ISS-science. For similar out-of-this-world stories, visit science.nasa.gov.